Hello, this is High Street Crossing Design, prepared for the City of La Mesa by San Diego Student Designs. I am Melissa Hamendi, the project manager. The purpose of the project is to design a cost-effective alternative for a new roadway crossing to connect High Street to Spring Street. A major component of this project is integrating smart growth principles into the design, which will provide access to commercial areas, reduce auto trips, and decrease greenhouse emissions. The crossing will thus shorten emergency response times for the military house complex on the west of the station and promote usage of the transit station in the area. The proposed design is at-grade two-way collector. I worked on the geotechnical evaluation also. Nino and Moore logs revealed metavolcanic rock topped by clayey sand fell. I observed that elevations at the site range from 598 to 548 feet. Through CAD, a profile of the crossing was developed showing cut-and-fill locations. 340 cubic yards must be imported to the site. Clearing, grubbing, and ground preparation are required prior to work. Retaining walls are also required to maintain street subsoil slopes. Pavement is designed based on County of San Diego public road standards.
Hello, my name is Brendan Anderson, and I worked on the transportation as well as construction portions of the High Street Crossing, especially with the transportation design and traffic impact report. The High Street Crossing can be evaluated as a two-way or minor collector as per the design. We analyze the average daily trips for existing conditions and future conditions with and without the High Street Crossing based off SandX Traffic Forecast Information Center in the year of 2020 as well as 2035. We predicted the design hour volumes and the directional design hour volumes for our roadways, as well as the level of service for the existing and future implementation of the High Street Crossing. We also analyze emergency response times existing and as well as implementing the High Street Crossing in. And with this High Street Crossing, it would reduce the time of travel for emergency responders on the City of Mesa to reach the High Street community by 4.4 minutes, as well as reduce the distance traveled by 1.8 miles.
Hello, my name is Emilio, and I worked on the structural engineering part of the High Street Crossing project. This involved designing a short-spanned overpass to allow cars to circulate through the whole extent of the parking lot, as well as multiple retaining walls to hold back soil on steep slopes. My goal in designing these things was to try and have a minimal impact on the other aspects of the project, as well as meeting as much of the AASHTO LRFD criteria that I had the ability to address.
Hello, my name is Philip Niver, and I'm the Water/Stormwater Engineer for San Diego Student Designs. As you can see from the overview of the project area, the proposed roadway will go from High Street through Spring Street Station and connect to Spring Street. When analyzing the area, we found two watersheds, one designated Watershed A and the other designated Watershed B. With these watersheds in mind and the quantity of water coming from them, we can plan how to go forward with our designs. After finalizing our design for the road, we noticed two areas that will capture additional water and not usually in the existing drainage system. Water from Watershed C will be captured by two inlets and diverted into a nearby valley. The remaining water from Watershed C and water along the road from Watershed D will be collected by two more inlets and will tie into the existing infrastructure.
Hello everyone, I'm Jack Wagner and I'm the environmental/stormwater engineer for this project. I'm here today to talk to you about the SWQMP. So a couple important BMPs that I chose to use were silt fences, stabilized construction entrances, and an engineering desilting basin, and all three of these are really good for sediment control. Here is a picture of a silt fence.
Hi, I'm Christina Minster and I help perform construction analysis for our design. Beginning with construction phasing, the optimum way to construct our design would be in three main phases. Since earthwork is a key driving activity in our project, we examined the profile of our proposed design and we saw that there were 3 distinct divisions in work based on the grade changes. And to minimize the impact on operating transit facilities, we broke down those phases. Where we were constrained to a window of 72 hours to work near the trolley tracks, for instance, we divided phase 2 into A and B in order to meet the time constraint. And it turned out this was the only phase requiring night work. It was estimated that our project would finish in 196 working days, which is less than 9 months in calendar days. Our project is estimated to cost less than $1 million, with the highest 2 categories contributing to the cost being pavement and earthwork. In conclusion, we evaluated our design on a triple bottom line criteria to assess the efficacy of our design in meeting our clients' needs. From the social aspect, our design effectively reduces the commute distance to and from High Street, thereby reducing the emergency response times and efficiently opening the last undeveloped land in the city of La Mesa for development. Moreover, environmentally, the shorter route design reduces the vehicle miles traveled and hence helps reduce the carbon footprint of the community. Lastly, the shorter route design also contributed to the cost savings by minimizing the area of work. And as always, thank you for choosing San Diego Student Designs for your design needs. We are proud to serve you.